Today we're talking about making use of hydrogen as an energy carrier. Remember, it's not a resource, it's an energy carrier. We can use it for storage, we can use it for a lot of things. Mostly today we're using it for petrochemicals and ammonia production, but we're going to talk about that. But it is viewed as an option for a green energy carrier. Depends on how you make it. So again, it's a carrier just like electricity. Electricity can be green or not, depending on how you make it. Hydrogen can be green or not, depending on how you make it. So we're going to talk about where we are in hydrogen, what are the possibilities for green hydrogen, and what does the future look like for hydrogen. All right, so this beautiful diagram was actually put together by the Department of Energy, kind of giving you the landscape of what hydrogen could be used for. Okay, so you can see the hydrogen, they're looking at it for all sorts of industrial processes. Some of these we do, some of these we could do. You can burn it, so anything we're using for heat, like we use natural gas for, we could in theory use hydrogen for. We could burn hydrogen to provide heat or electricity production even, either directly from burning it or things like, you guys had a video on fuel cells where we can turn hydrogen into electricity that way. So you can see it's kind of integrated with the gas infrastructure. It could be for electricity production. It could be for transportation, lots of different theoretical options. So what we're going to talk about today are what are the challenges of some of those options and kind of what the potential really is. So energy currency, it's simple, burns really easily. When you burn it, you only get water, right? So it's a carbon-free at the burning of it. Whether it's carbon-free from a life cycle standpoint depends on how you made the hydrogen. When you burn it, you get water. There's lots of hydrogen on planet Earth, but it's bound up in other things, right? Our hydrocarbons have a lot of hydrogen in them. They're CHs, right, of different aspects. So we have a lot of hydrogen. We have it in our water. We have a lot, but it is generally not found by itself. And we'll talk about that a little bit. You'll probably have heard different colors of hydrogen, green, blue, gray, yellow. We'll talk about what those mean. The hydrogen itself is a colorless gas. And what we find and what we're using is H2. We're not using the single atom, we're using H2. That's what we're burning. We're breaking that molecule apart to get energy and water. The color doesn't have anything to do with the hydrogen itself. The hydrogen is all the same. The color is just about how you made it. So it gives you a sense of kind of the carbon intensity of the making of that hydrogen. Mostly made from natural gas today. We'll talk about that. Potential to be made from green sources because we can make it by breaking it out of water using electricity. And if that electricity was green, then you have carbon-free hydrogen. Lots of different potential markets. Today, it's really used for rocket fuel, refining, and ammonia production. Those are kind of the main areas we use it today, but there's a lot of other things it could be used for. But one of the things we're going to keep in mind as we're talking about hydrogen is like we talk about with other energy systems, every time you do a conversion, you have losses. And so I just kind of put 3 examples up here. We'll look at the details later, but if you're trying to use green hydrogen to make electricity, and you're using it from renewable sources, you're making electricity to make hydrogen to turn it back into electricity, that's going to be a lot less efficient than if we're just using that renewable to make electricity directly. So there has to be a value add. There has to be a reason, and that might be storage or something else to have those efficiency losses. And we'll look at exactly what those look like. Okay, so that's like the map of what we're doing with hydrogen today. So here's our periodic table. I think it's the first time we showed it in class today, but you'll remember this, right, from chem class. There's hydrogen, our simplest little atom up there. So it's a colorless, odorless gas, like I said, highly combustible H2. When I say highly combustible in the atmosphere, because it reacts really easily with oxygen, oxygenates really easily. So even at low concentrations, if you have a leak out of a hydrogen pipeline or something, it's going to catch on fire. It takes very little spark for it to catch on fire. I worked, you guys know I worked at Dow Chemical for a few years in a chlorine production facility, and one of our byproducts was hydrogen. The way you make chlorine is you electrocute salt water, basically, and break apart the salts to get chlorine out. You're also, when you're electrocuting salt water, you're also electrocuting the water, and you get hydrogen out as well. And so we had a whole hydrogen facility, and one of the big things is you can't see a leak and you can't see a flame, but you can hear it. And so finding if there was a leak that had caught on fire could be challenging. And it's a very small molecule, so it leaks pretty easily. So we had to have special gaskets and stuff on those kind of pipes. We often were either venting the hydrogen out of our hydrogen facility, which was just wasting it, right? But it was just a byproduct. Or sometimes we compressed it and put it into the natural gas system. So it got burned along with natural gas. So you can do that with small percentages. We'll talk about what California allows. You can put a little bit of hydrogen in the natural gas system, but the natural gas system isn't really set up to move hydrogen around. It's not set up for the small molecules. You can have embrittlement with steel where it can actually degrade the pipeline. So it's not like we could switch our natural gas system over to hydrogen without a lot of upgrades. Okay. Every once in a while, those big vents, when we were venting hydrogen, would catch on fire, and then you hear it. You couldn't see it, but you could hear this loud, like fire burning at the top of the vents in the at the chemical industry where I worked. So anyway, I'll talk a little bit more about some of that experience. Okay, I said we have a lot on Earth. We have a lot of hydrogen in the universe. We'll talk about fusion later, right? But that's what the sun is doing. It's fusing hydrogen together for energy. We're trying to do that here on planet Earth as well. So we'll talk about fusion later in the quarter. Like I said, it mostly exists in other ways. Oxidation, that's a carbon-free. It's nearly invisible when you're burning it. Hydrogen is very energy dense from a weight standpoint, but not from a volume standpoint. So think about that as like it's a gas, right? Just like we see with natural gas, right? In its natural state. So very, very energy dense from a weight per molecule, but if you're thinking about it as a gas, we'll show some pictures of how it looks compared to other things. So you've seen this map before, right? Where does hydrogen fit? Hydrogen is this energy currency. We have to use a resource to make it. We could use it for energy storage. So you think about, you could make it, you could store it, and then you could use it later to get the service that you want, right? So for hydrogen. I put a little question mark here on resource because there are people investigating geologic hydrogen, where hydrogen actually does exist in our crust. And we'll talk a little bit about that. So doesn't really, that would make it sort of like an energy resource if we were able to get it from the ground rather than having to create it. Okay, so here, I said I would compare these things. Here's hydrogen compared to things like batteries and diesel and gasoline in terms of energy density. And so you can see very energy dense by weight, but very low energy density by volume. So if you're going to use it in an application like transportation, you really have to compress it, which takes energy, or you have to put it in some sort of stratus. We have other materials that you can put the hydrogen in order to get enough of that hydrogen, basically to be able to use it for transportation. This matters less when you're using it for something like energy storage, but it can still matter in terms of the volume it takes up. So it's kind of like, what is hydrogen? Let's talk about how we generate it today and how we move it or could move it. Beautiful colors of hydrogen. These have moved around. Sometimes somebody comes up with a new color of hydrogen, but I've tried to collect them all here. The ones we talk most about are gray, blue, and green. So gray is the predominant way we make it. That's from steam reforming of natural gas that produces carbon, CO2 emissions. So that is considered gray hydrogen. We do also, places like China do produce some hydrogen from coal. You can gasify coal and also get hydrogen out. Blue would be doing the same thing as gray, but now you're doing carbon capture and storage along with that production of hydrogen. So now you're lowering the carbon intensity of the hydrogen you're producing if you're doing blue. And then of course, green is what we were just talking about. If you're producing electricity that's from renewables to make hydrogen using electrolysis, that's carbon-free. These other ones kind of fall, some of them fall in the middle. Yellow is if you're just using grid electricity, so it would be lower carbon likely than the natural gas because you have a variety of carbon-free resources, so you have kind of a mix. Pink is from nuclear energy. You could use nuclear both through electrolysis and from heat for nuclear. This is kind of a new one. I've seen it called both white or gold. This is like geologic hydrogen, if we found natural deposits of it. Turquoise is kind of in the middle. It's like you're basically capturing the carbon in a different way than doing carbon capture and storage using solid carbon. So again, the colors, hydrogen is all the same. The color is about how did we make the hydrogen? And generally it's a different color because of the carbon intensity of how we made that hydrogen. So now when you read the articles, you'll know what they're talking about when they say gold hydrogen or turquoise hydrogen or some other color they'll come up with. So what do we do today? So almost all of the hydrogen today is produced from fossil fuels, and that's without carbon capture and storage. So again, most of this is from natural gas, about 2/3 is natural gas. Some of it is byproduct, that's in the refining industry often. So when we're taking our oil and making it into other fuels, we do produce some hydrogen, and then we often use that back in that same industrial system. So that's another place where we're producing hydrogen. We are seeing an increase in hydrogen demand and consumption, but a lot of that has to do with the things that we're already using hydrogen for. It's not necessarily for new ways or ways of decarbonizing our systems. It's still very early stages for that. So you can see electricity making hydrogen is a very, very small part of the global pie right now. So how does it work? There was a video on this, so you guys saw kind of how steam reforming of natural gas works. I'm not going to go into the details, but suffice to say that you're using heat, steam, basically with the methane, and you're breaking off the hydrogen molecules to make hydrogen and carbon monoxide from natural gas. And so you can see we kind of get this reaction, and you're getting CO2 and hydrogen out of the reaction. Very cost-effective way of making hydrogen, which is why it really dominates the landscape. Oh, and this is just, sometimes this is called steam methane reforming, so SMR, not to be confused with small modular reactors, which are also called SMR. That's nuclear. Okay, so just industry terminology. So you guys are aware of the acronyms. Okay, and then we can make hydrogen from electrocuting fresh water, basically. So you're just basically breaking apart your water molecules, water H2O. You can break that apart. You have a membrane system in order to separate out the hydrogen and the oxygen that you're making, because you don't want those to mix back together. They will react and form water again. Then in very low concentrations. So you have a membrane that allows those protons to pass through, so you can separate out the hydrogen and the oxygen from each other for the electrolysis. This is a more expensive way of making hydrogen, which is why it's such a low part of the system, especially since if we don't have a price on carbon, there's not really a reason to do this unless you're just motivated to decarbonize your hydrogen. So to give a sense of the cost of hydrogen production, this is the latest study that I've seen on this. You can see kind of the difference in the cost for something like the methane reforming, which is what kind of dominates coal gasification, and then electrolysis, to just give you a sense of it's very different price points for that. I don't want to forget about geologic hydrogen, just because there's a lot of interest in this space, but maybe not a lot, there's not production happening yet. This was a great study that kind of shows the ways that we could have hydrogen produced and stored in the subsurface, and how that would happen. And there are companies that are looking at this, and I said orange is another color that's coming into, maybe there's orange hydrogen, but gold hydrogen, that's geologic. So there haven't been vast geologic stores of hydrogen found, but there are in theory some in existence, and there's some companies that are checking that out. Okay, so that's how we make it. Now let's talk about moving it. Like I said, we can't just basically stop moving natural gas in our pipeline system and start moving hydrogen. You would have to do a lot of upgrades to that system and basically build up a new system to have it be pure hydrogen. Hydrogen can embrittle steel in the welds and the pipelines. Like I said, it's a very small molecule. California allows us to add about 5% of hydrogen. That's kind of what we did at Dow when I worked there. It was about 5% when we put our hydrogen into our natural gas system and just burned it in our combined cycle power plant, basically. So it was just kind of, it was a byproduct. We could put it in there at small percentages, but you can see we have a small hydrogen pipeline system, but compared to the natural gas system, it's not significant. So transportation of hydrogen is a challenge. You can transport it by truck and things like that, but you have to remember it's very low volume, so you have to compress it, or it's much harder to liquefy than natural gas. So transportation is certainly a challenge for hydrogen. Now let's talk about where we use it and a little bit about where things are going in the future and who's investing in that. So I mentioned this already. Where do we use hydrogen? This is just the global breakdown. We use it primarily in refining. So we use hydrogen to upgrade our fuels to the gasoline and diesel and jet fuels that we want from the oil, the crude oil that it comes from. And so we're often adding hydrogen back in to upgrade those fuels. We use it for ammonia production. This is primarily, for agriculture and other things, but you also can use ammonia as a transportation currency, an energy currency. A carrier of hydrogen. So we're talking about energy use. There are shipping companies and stuff that are looking at ammonia as a hydrogen, basically an energy carrier for transportation. And then you can see small amounts for methanol production or iron and steel and other things. So we went from that big picture, right, of all the ways we could use hydrogen. There's a lot of different markets and aspects of that. This is what we're doing and what we've been doing for a long time. It's the same picture in the US, just slightly different percentages, but again, mostly refining and ammonia production in the United States. So that's what we're doing today. But most people are talking about the future, right? So what are we going to do? What could we do? What could happen with green hydrogen? And so let's talk about that. So this is showing you what we've been doing and kind of what's predicted. So a lot of the growth that we've seen in hydrogen is because we have growth in demand for fuels or growth in demand for ammonia. That's what we've been doing. But there is more investment going in to clean hydrogen or green hydrogen or blue hydrogen, other things. So what I'm showing you here is this is all energy and industrial investments by technology. So you can see kind of how hydrogen stacks up against other investments like solar and wind, but there's definitely been a growth in this space. Just going down to the things by technology, because we could get a little bit more recent data on it, you can see that growth in hydrogen investment has continued in terms of green hydrogen or new ways of making hydrogen. So definitely excitement about it. One of the aspects to think about in terms of all the different ways we could use hydrogen is that those different markets have different price points, right? So we saw that SMR is way cheaper way of making hydrogen than electrolysis, but it can depend on the market what price point you need to get to for it to be competitive with other things in the market. And so if you're thinking about the potential roles of hydrogen, this is kind of my list. For the electricity system, it could be long-term energy storage. For example, for transportation, you can use fuel cells. I would say most people would say for personal vehicles, electric vehicles have kind of won out. They're just more cost effective and simpler than hydrogen fuel cells. But I would say there's still question about mid and long range, trucking, airplanes, ships, these longer things that are harder for batteries to really dominate. So we're kind of seeing what happens in that space. And then there's a lot of applications in industry where we could decarbonize that, where we can use hydrogen instead of natural gas or coal or something else that's either providing high heat or for steel production, things like that. And then, of course, you can use it for heating. We talked a lot about electrification of heating in buildings. I think for these low temperature applications, electricity is going to make a lot more sense. Hydrogen might be more competitive when you're talking about high heat, where it really helps to be burning something for it. Okay, so it's kind of landscape. So let's look at them and let's look at efficiency. We're just going to look at a few examples. Okay, so if we wanted to use it for something like a low temperature application like heating a building, this is why electric heat would make more sense than having something like a hydrogen boiler in terms of basically the heating value you get out of that, making that renewable hydrogen. So remember, this is like thinking about like if you're making green hydrogen from renewables and turning it back into like a heat, it's going to be more efficient to use that electricity directly than use it to make hydrogen and then turn it into that service. So that's just one example. Another thing we can use hydrogen for is storage. This is a little bit older chart. So batteries, I think some argue that they are getting into the kind of the week versus just the day time frame. But we could use, in theory, hydrogen for long-term storage on the electricity grid, right? You could make the hydrogen with electricity when you have excess. You could store it. You could use it later, take summer sun and use it in the winter, something like that. The challenge with this gets to be economics, not technological, because if you think about it, your battery, if you're getting sun during the day and then you're using it at night, and then you're getting sun the next day and you're using it at night, then you get payback, right? That's arbitrage. If you're using sun during the day in August and then not using it until January, that's like one exchange in terms of getting a price arbitrage. And so it really gets hard to do long-term storage economically, even though technologically we could do it. So just to give you a sense of what the efficiency looks like if we were thinking about using it as storage. So this is lithium battery storage and your efficiency for that system. Pumped hydro, which we talked about, and then talking about hydrogen. You get much less of that electricity back if you're doing that for energy storage. And so that also makes the economics harder. If for storage, you can store it in all sorts of different things. If we wanted to do hydrogen storage, one of them is to store it underground. There was a study that was done on different ways that we could store hydrogen and the cost points. You can see there's kind of a range of it. But again, it's hard to make some of that economics work, especially with the efficiency losses. You could use hydrogen for transportation. This was actually a chart put out by Shell, looking at, battery electric is kind of at the low end, hydrogen, fuel cells might make sense in the middle, and then, from their standpoint, we've got to still do liquid fuels for the long range things. So we do see hydrogen vehicles. You can buy fuel cell vehicles, fuel cell trucks, buses. Really interesting, we've seen a lot of forklifts go either electric or hydrogen-based. If you think about that, that's much easier from a fueling standpoint because they're often working in a relatively small space. And it, when you're thinking about the air pollution impacts, you're taking that point of air pollution out of a warehouse or something where people are working. So we've seen both electrification and a switch to hydrogen for forklifts. Airplanes get really interesting. We've seen short haul airplanes both for electrification and hydrogen. So I'm just saying that it is another area that people are investigating for an option for hydrogen fuel cells. So just again, looking at the efficiency, if we were looking at our electric vehicle and our hydrogen vehicle, it's hard to get that the economics to work as well. If you're using green hydrogen, you're using electricity to make your hydrogen. We can use hydrogen in steel production, and this is really a place where hydrogen provides the opportunity to decarbonize steel production. Microsoft has made some big commitments of buying green steel, so basically decarbonized steel for their needs for steel. Steel is a huge part of CO2 emissions. Lynn's going to talk more about that in terms of these harder to decarbonize sectors. So Hydrogen does provide us that opportunity. Again, there has to be demand for having that decarbonized steel because it is less economic right now to make that green hydrogen that would be carbon free. And this is just a little bit more about the process and what that looks like. Okay, so I mentioned all these different markets kind of have different price points that hydrogen needs to get to in order to compete in those markets. So what I'm showing you here is kind of like industrial heat, seasonal storage, iron and steel, competing with biofuels, forklifts. So you can see kind of the willingness to pay for that hydrogen can be very different depending on the service it's providing. So it's not like that service looks the same for all different sectors. Okay, what are some of the challenges? I think the biggest challenge are economic for clean hydrogen or green hydrogen, followed by the infrastructure that you would need to provide that energy carrier to provide these services. The Biden administration had a lot of goals around this. They had this national clean hydrogen strategy and roadmap, $1, 1 kilogram in 1 decade. Much of that has been put on hold or just stopped completely under the current administration. We were going to have these hubs around the country. The 2 West Coast hubs have basically had their federal funding terminated, both the California one and the Pacific Northwest one, of about $2 billion. And the other ones are under review. So their funding hasn't been ended yet for Texas, Midwest, Appalachia, Mid-Atlantic, but it's under review. So it's still very uncertain in terms of that federal investment. So you can kind of see this is just kind of like a smattering of articles about, green hydrogen's future in the United States investment is pretty uncertain. I wanted to bring back to a local example. So then this is one of the places we actually go for our field trip. This is the Lodi natural gas combined cycle power plant. At the time it was built, which maybe was a decade ago now, it was the most efficient natural gas combined cycle power plant ever built. It uses wastewater for cooling. When we first started going there on field trips, it was very much part of the energy mix here in California. After about 3 years, it started getting used less and less. So as solar and wind really came on the grid, it was used less as this kind of baseload resource where they were really, making a lot of revenue, and used more as a balancing resource. So they were turning it down or turning it off in the middle of the day and bringing it back on at night when the sun was going down. So from their standpoint, it was less cost recovery for the investment they made in this power plant because they weren't getting paid as much for energy production. But they could participate in other markets. So one of the things they were looking at is changing it from natural gas to hydrogen. So a hydrogen facility, they have funding. This is kind of a recent article on this. Its plan is kind of to have a mix of hydrogen and natural gas and using excess renewable power and the adjacent wastewater to make the hydrogen on site and then use it in the power plant. They've been talking about this project for a while. They've done some of the studies on it, but it's pretty early stages still. The funding, especially right now, is pretty uncertain. So we'll see where that goes. Okay, so where are things happening? Where are things happening, guys? China, right? We keep bringing it back to that. Hydrogen is no different. So China is investing a lot in electrolyzers to make green hydrogen. So this is showing, global operational projects by country. So you can see the capacity that they already have in place for electrolysis hydrogen, and their plan is to continue to grow in that capacity in China. So they're definitely investing in that. In terms of what it looks like in terms of projects, so this is not what's happening, but this is what people are talking about. Oh, yeah, question.
With solar energy technology getting less expensive, do you see the same happening for hydrogen?
I think we kind of see that with any technology. So the electrolyzers and the systems they're using, there's different kinds of electrolyzers. And we even were testing out some GM had that were this proton exchange membrane systems. We use electrolyzers in industry, like I said, for making chlorine, which we've done for a long time, which is an input into plastic. So the use of electrolyzers necessarily isn't that new. It's just using it for green hydrogen. But I would expect that as you scale any technology, you will see economies of scale. And so China's kind of making that investment and that bet. And I think what we've seen in other things China's doing, they want to be the one to sell it to other countries. If they want to make green hydrogen, they'll come to China to buy the technology or the systems. Yeah. So certainly there's that potential. We're just not seeing a lot for demand for green hydrogen right now. So China's planning to continue to grow this. They have a lot of things in the pipeline. This is what the pipeline looks like. So this is not, these are like everything from feasibility study, concept, demo, because that's kind of where hydrogen's at. The US has looked a lot more at carbon capture and storage, I would say, than the rest of the world. The rest of the world is really looking more at electrolysis. But that's, when we're saying the rest of the world, that's really China and the US. Okay, so there's not a lot going on, and there's a little bit going on in Germany and things, but not a lot. All right, what's going on at Stanford? So we do have a class in winter quarter called the Hydrogen Economy. If you want to learn more about it, there's a student club. There's a podcast that's run out of Precourt, the Hydrogen Innovators podcast, so you can learn more about it. We have professors. You can go to our the hub and look at who's working in this space if you kind of want to, if you're interested in hydrogen and kind of want to see what the latest is happening. And we've already talked about all these, so this is just a summary slide for you guys to refer to about where hydrogen is on our landscape. If you want to learn more about this topic or other energy topics, visit our Stanford Understand Energy Learning Hub for free resources, including signing up for our monthly Energy Spotlight. Don't forget to subscribe to our YouTube channel and tap the notification bell to be notified for our newest content.